In this video, we will demonstrate how can we design and use a testing form for the particular case where we have a variable number of samples or a variable number of parameters that are measured. So let's log in. So let's analyze together the technical documentation for this use case. We will design a form for testing wastewater effluent, the total suspended solids. We have prepared a document with all the necessary details. So let's start implementation. First of all, let's see what measurement units are we using. We have liter, milligram per liter, and percentage. Let's check if we have defined these measurement units. Milligram, we don't have it. Liter, we have liter. Milligram per liter. And percentage is already present. Okay. So now let's see what normatives are we working with. It's this one. Let's specify it. Okay. And now let's analyze the use case for designing our form. So we see that we can have a number of samples between 3 and 20. So the number of samples can vary from test session to test session, but it's very important to make sure that we are within the range, not less than 3 and not more than 20 samples for a given analysis. So, what measurements? So first we have a variable number of samples. In this case, we have 4 samples, which is okay because it's bigger than 3. We have 4 samples. And for each sample, we have as measurement value the volume and the dry residue weight. Okay, let's start our form design by adding these measurements. Forms, new form, which will be named like this. Okay, let's put it on the bottom of the list and start designing the form. Okay, so add these new parameters, these first measurements. First is aliquot volume. The value type, it's a numeric value, but because we have a variable number of samples, we don't know how many samples, we will define this parameter as an array. We will mention that is a parameter. It will not be shown in testing reports. Okay, measurement unit, it's liter. Okay, and we can save the parameter. Add a new one, dry residue weight. Okay. The value type is also numeric, and also this one is an array. It's also a parameter. It will not be displayed. These are just measurements. They will not be displayed in testing reports. Measurement units, milligrams. And that's all for now. Okay, what else do we have? Now we have some calculations. First, we have to calculate the value for total suspending solids. Total suspending solids. Okay, let's add it. It's also a numeric value, and this one is a scalar value, is not a vector value. It is calculated in here. The result is calculated in here. So this is the formula. And these are the calculations. So it's not an array, it's not a parameter. It's shown into the certificates or testing reports. It's used for certification. Measurement units, it's milligram per liter. This is the normative. Okay, that's it. What other parameters do we have? The relative standard deviation, it's another one. This is This is a percentage. The result is presented as percentage. So it's a numeric value. It will appear for certification, measurement units, it's percentage. And this is the normative. Okay, we added this one. And here we have this normalized value, which is calculated in here. This normalized value is calculated based on the measurements, based on the given measurements here. We can see the calculation. And this one appears both here and here. So because of this, I will create another parameter for this one. Add new parameter here. It's also a numeric value, but it's an array. We can see that it has multiple results, so it's an array. It's parameter. It will not be displayed in testing reports. And the measurement unit, it's milligram per liter. Okay. And we have one more parameter for this form. Because the sample size, because we need to validate the testing results based on sample size, we will have to add it in here. Sample size. It's an integer value. It's scalar. It's not an array. It's just a value. It's not a parameter. So it will be displayed in the testing reports. And we don't have a measurement unit. Okay, let's save it. Okay, now let's start introducing the calculations, the formulas for calculating normalized value. Let's start with this one. Normalized value. It's a calculated field, and it contains the ratio between the aliquot volume and dry residue weight. Okay, this is it. Let's continue. Now we have to calculate the total suspended solids. It's calculated, and we have the average of these values. Okay, so the calculation is average of these values. And it will return a scalar value. Okay. Next one is the relative standard deviation. The relative standard deviation is this one. So it's a calculated field, and we will say let's calculate this array first. It's the squared deviation from the mean, which they calculated in here as a demonstration. So square deviation is okay, is calculated xe minus average square. Okay, so we have all these values, and now we have to calculate this sample standard deviation. S, simple S, is of sum of this standard squared deviations from the mean divided by the sample count minus 1. The sample count minus 1. Okay, and let's return this value. Okay, and the sample size, it's a calculated. Let's put it to count the number of elements of this parameter. Okay, let's rearrange the form a little bit. Calculated fields first, the sample size, and this intermediary calculation here. Okay, and I think we can submit the form and perform the validation. So let's try to validate this form. Okay, so we forgot something. You know, this data, for each volume, we have a corresponding weight. For this volume, we have this corresponding weight. For this one, we have this one. Because in order to create this relation between these two parameters, we have to make them part of the same group. Not this one. Yeah, this one. Yes. Group 1, for instance. Okay, and put this column also in the same group. And now they are bound together. These two parameters are bound together by using this group indicator. Okay, let's add the test data. The control is changed. And let's start adding the data. 1, 2.5. Next one, 0.513. Uh, 0.256. 0.25. Okay, so we added all the measurements, and now let's put the expected results. Total suspended solids, what is the expected result? Let's go down. Is this one, 25. Relative standard deviation, it's this value. This is the expected value, which should come out from the formulas. we designed earlier. What else? Sample size, it's 4. Okay, and we have to add these calculations 0, 1, 1, 0. 0, 1, 1, 0. Okay, let's save and calculate. Okay, so let's find out what is wrong with our formula. So the sample size is correct. The normalized values are incorrect. Let's check the formulas for normalized values. The formula is wrong. We had weight divided by volume, but here is the other way around. This is one mistake. We catch it before using this form. It's not fixed yet. Let's see what other problems we have. Yes, I used the wrong values for the expected values. I put the wrong values. "26, 24, 25. Save. Okay, we still have a mistake in here. Let's check the data. It's 1, 0.5, 0.25, 2. Ah, yes, I found it. I found it. It's 25. Sorry, it's 25. It's this one. 25, 13, 6 and 5. 13, 6 and 5. Okay. Yes. So now we fix the normalized value. It's calculated correctly. This situation appears in designing this form, so it's very good to have the possibility to test, to validate the form before using the form in production, using multiple test data to make sure that the form works as expected. So we have just one more parameter to fix the formula for relative standard deviation. Let's see what the formula we use. Okay, and let's compare with the document here. Okay. We have this one, the square deviation from the mean. It's this calculation. Okay. The standard deviation, this one, is the square of sum of these values. Okay. Divided by the number of samples minus 1. It's okay so far. And we got this value. Okay, but we should add also the final value is this one. Is this one. And it's this one divided by this one. And multiplied with 100. And the actual result is this one. Okay, let's see the, okay, the value is closer. Okay, we have more decimal places. Let's see. Okay, the batch variance percentage must be reported to exactly, wait, relative standard deviation. Relative standard deviation should be reported to exactly 2 decimal places. Okay, it means the expected value, it's wrong. It's this one. The expected value, it's this one, because it has to have only 2 decimal places. So this is the expected value. And in this case, we have to round this value to use 2 decimal places. Okay, and now we are all green. But we are not finished yet, because there is one more requirement mentioned in here. They say the total suspended solids must be rounded to the nearest whole integer. So it should have no decimals. But if the value are smaller than 10 milligrams per liter, it has to be rounded to 1 decimal place. So we have to implement this in the formula on total suspended solids. Edit. we will put this total suspended solids, and the result will be if TSS is greater or equal to 10, then we will have no decimal places. Else, if it's smaller than 10, then we will have one decimal place. One decimal place. Okay. Okay, I think we finished the implementation of this form based on the data available. And apparently it checks out because all the formula validation, it's green. So let's just add here title, save. Okay, and I think we can validate the form. And let's try to use it. First, we will define a material, add a new material, this one. With this norm, save, and associate the applicable tests for this one, or these ones we defined earlier. Okay. Now let's define a specification. Our material is here. We added the specification, and let's add the restrictions from our documentation. So we need to have this value must be lower or equal to 30 milligram per liter. Lower or equal to 30 milligrams per liter. And now let's validate this formula. For instance, if we have 25, we expect to pass. If we have if we have 30, a value of 30, we also expect to pass. But if we have 32, we expect to fail. Okay, our formula is verified, everything is passed, we are getting the expected results. And let's go to the next one. for the next one, the value must be lower or equal to 5%. It must be lower or equal to 5. Okay. Let's test. Let's add some validation tests. If the value is 3.2, we expect to pass. If the value is 5, we expect to pass. If the value is 5.7, we expect to fail. Okay, the condition has been verified. And let's add the last one, the sample size, which has to be between 3 and 20. Greater than 3 and also greater or equal to 3 and also smaller or equal to 20. Okay, let's put some values to test this condition. Let's say if we have just 2 values, we expect to fail. If we have 3, we expect to pass. If we have 5, we expect to pass. If we have 20, we expect to pass, but if we have 21, we expect to fail. Okay, the condition is verified. So now we have a valid specification. We will submit it. And let's use the form and the specification. Let's make a sample reception, add a new certification, select our material, okay, and now let's select the form, add the testing form. We will introduce the same values we used for testing the form. 125, 125, 0.513, 13, 0.25, 6, and the last one, 0.25. Okay, we will save changes and submit changes. And these are the values the measurements and also the calculated values. Let's switch to table view to have a better understanding of the data. And now let's preview the testing report, but we don't have, there are no reported test measurements. We will have to go back, and after analyzing the results, we will report these measurements, this data, and they will be available to be published. Preview the testing reports now, and we have all the values present. We will submit the testing report, and we can see this testing report, which is now published and available to be consulted by internal clients of the laboratory. Okay, now let's also generate the quality certificate. This is the pending certificate. The quality certificate can be composed based on one or several testing reports. The testing report is generated by the laboratory personnel, but the certificate is generated by some person which is in charge of quality control into the organization. So this certificate is not redundant with the testing report. For instance, within your laboratory, you have 2 departments, and each department may test different aspects of the sample. Each department will independently release its own testing report. The quality control responsible is the one which compile together all these all these testing reports within a quality certificate. So we have this certification pending. We will add it here. We can check the actual specification. We can check the testing reports where the data came from. Here we analyze the results, but they are already confirming here. And we will submit a certificate. And now the certificate is submitted. So we completed all the journey from creating the testing form. We use the testing form, and we continue with the certification of that sample. That's it for now. Please leave your comments in the section below. Bye.